In this video, we will build a jaw-dropping, realistic neon glowing sign layout with a built-in voltage drop flickering effect, using nothing but pure HTML and CSS. Let us build a stunning, high-contrast neon tube light display. I am going to show you how to write out a multi-layered text shadow emission matrix, step by step. Let us jump into the body tag. First, I am going to build our master staging framework by writing a div tag with the class neon-container. This creates a targeted structural grid environment to isolate our text graphic alignments safely. Inside this housing wrapper, I'll create our primary sign typography by writing an h1 tag with the class neon-text. I'm going to type the string live feed directly inside our h1 headers to populate our physical display characters. Let back up inside our style tags and add the CSS. I just add some basic style to the body. Next, let's configure our primary layout grid by typing the class selector dot neon-container. Inside, I'll write text align center and padding 40 pixels to pad out our element field smoothly. Now let's build the core lighting graphics by targeting our text selector using the class .neon-text. Inside this block, I'll type font size 64 pixels and font weight 900 to ensure the characters are thick enough to mimic physical structural glass tubes. I'll use text transform uppercase to convert all letters to solid capitals and write letter spacing 6 pixels to separate the glowing characters evenly. To simulate real lighting glass cores, I'll add color #FFFDFA to paint the physical center line an ultra-bright, almost pure white light tone. Now for the master multi-layer ionization emission matrix trick. I'm going to build out an extensive text shadow matrix. I'll write 004 pixels #FFF as our first tight core layer to keep the tube bright white. Then, I'll layer on 5 sequential ambient glow lines to build our gas bloom field. 0010 pixels #FF0055. Then 0020 pixels #FF0055, followed by 0040 pixels #FF0055, 0080 pixels #FF0055, and finally 00120 pixels #FF0055 to create a beautiful, wide, glowing pink magenta neon gas aura. To bring the sign to life, I'll link our custom animation timeline by writing animation neon flicker 3 seconds infinite alternate and close our bracket. Let's write out the advanced voltage drop mathematics keyframe blocks. I am going to declare our timeline tracks by writing at keyframes neon flicker. First, I'll map out all our fully energized stable voltage frames. I'll type out the comma-separated timeline steps: 0%, 19%, 21%, 23%, 25%, 54%, 56%, 100%. Inside this massive baseline block, I'll declare our complete text shadow matrix: 0, 0, 4 pixels #FFF, 0, 0, 10 pixels #FF, 0, 0, 5, 5, 0, 0, 20 pixels #FF, 0, 0, 5, 5, 0, 0, 40 pixels #FF, 0, 0, 5, 5, 0, 0, 80 pixels #FF, 0, 0, 5, 5, 0, 0, 120 pixels #FF, 0, 0, 5, 5. Color #FFFDFA. Now, to simulate rapid power drops, I'll target the spaces between those frames by writing the selector group 20%, 24%, 55%. Inside this voltage failure block, I am going to pull the text shadow fields back down sharply to just 002 pixels #FFF, 004 pixels #FF0055, and 0010 pixels #FF0055. This instantly collapses the wide gas halo field. I'll finish this rule block by setting color to #8A1A3A. This dims the core letter characters to a dark, unlit hot filament magenta tone, the exact millisecond the voltage drops. As we hit save, our code executes cleanly. Our neon sign glowing component renders perfectly on our ultra-dark luxury layout canvas. Thanks to our multi-layered text shadow engine, the characters emit a realistic, soft neon gas bloom. The moment our asymmetric keyframe tracks cycle, the gas fields drop and re-ionize instantly, producing a completely organic, electrical flickering sign look, powered entirely by hardware-accelerated CSS calculation loops. Thanks for watching. If you found this real-time build helpful, make sure to drop a like and subscribe. See you next time.